Today, we're going to look at a theory that does more than just challenge our understanding of physics. It suggests that the very fabric of reality, well, it's not what we think it is at all. I mean, it's the oldest question, right? For centuries, we've smashed atoms, we've mapped out energy fields, we've dug deeper and deeper. But what if the answer isn't smaller particles or weirder energies? What if the very foundation of reality is something else entirely? And that is the radical idea we are diving into. A proposal that says the universe, at its most fundamental level, isn't made of stuff, but of pure information.
Okay, so right off the bat, you might be thinking this sounds kind of philosophical, like a metaphor. But it's not. This idea is actually grounded in some really solid, hard physics. And to get it, we have to start with a proven scientific principle. This is called Landauer's principle. And what it says, basically, is that whenever you erase information, think about deleting a single bit from your computer's memory. It's not a free action. It takes a tiny but very real amount of energy. And that energy creates a little puff of disorder, or entropy, in the world around it.
Let me be super clear. This isn't a theory or a neat idea. It's an experimentally confirmed fact, and it's the solid ground we're building this whole explainer on. Information isn't just an abstract concept. It has a real, physical footprint in our universe. Okay, so hold on to that idea. Information is physical. Now, let's turn to the biggest crime scene in all of science, the quantum world. For about 100 years, it's been throwing up one baffling clue after another. First up, there's quantum entanglement. You've probably heard of it. Einstein famously called it spooky action at a distance. You can have two particles, and if you measure one right here, its partner, even if it's on the other side of the galaxy, instantly knows. How in the world does that work? And then there's this weirdness, the measurement problem. Before you look at it, a quantum particle can be in a whole bunch of states at once. But the instant you observe it, bam, it snaps into just one definite state. It's almost like reality waits for us to look before it makes a decision. Now, don't get me wrong, we have some brilliant explanations for each of these things. We've got math for entanglement, theories for measurement, principles for uncertainty. But what we don't have is a single story that connects them all. They feel like clues from the same mystery, but we've never figured out how they fit together. And this is where a new theory steps onto the scene. A theory that takes one look at all these scattered clues and says, wait a minute, what if these aren't separate mysteries at all? It's called Informational Quantum Dynamics, or IQD for short. And its core idea is that quantum mechanics isn't fundamentally weird. Instead, all of its strange and spooky effects are just the totally natural result of one simple rule. Information has to flow along a very specific geometric path. Now, this framework was developed from the ground up by Kevin L. Brown. He's an independent researcher, inventor, and author who was looking for a more fundamental reason for all these quantum puzzles. IQD basically flips the whole problem on its head by asking this really powerful question. It suggests we've been so focused on the symptoms, the entanglement, the collapse, the uncertainty, that we've missed the single underlying cause that links every single one of them. So the big question is, how does this one idea, a geometric highway for information, actually solve the biggest puzzles in physics? Let's break it down. The logic here is actually super straightforward. It gets rid of all the complex, separate explanations and replaces them with one basic rule. Think of it this way. Reality is a flow of information, but that information has to stay on a specific road. And it turns out all the quantum weirdness we see is just a side effect of that one traffic rule. All right, let's see how this actually works. That collapse that happens when we measure something, IQD says that's just the information of the system snapping back onto the only geometric path it's allowed to be on. And that spooky entanglement, that's just two particles that happen to share the exact same alignment on that path. So whatever happens to one has to happen to the other. And uncertainty, well, that's just built into the natural curves of the road itself. See? One idea, multiple solutions. It's elegant. Okay, that's a really neat story, right? But is it science? For it to be real science, it's got to have a solid mathematical foundation. And even more importantly, it has to make predictions that we can go out and actually test. And it does. IQD isn't just a concept. It's a full-blown mathematical theory. It's built around its own master equation that describes exactly how this flow of information is supposed to behave. Now, this is probably the most crucial point. This theory doesn't throw out 100 years of physics. It actually includes it.
What IQD shows is that in simple, very orderly systems, what scientists call the low entropy limit, its master equation mathematically simplifies and becomes the famous Schrödinger equation. And that's the equation that has successfully powered quantum mechanics for a century. So IQD stands on the shoulders of the science that came before it. And here's where the rubber meets the road. IQD makes specific, testable predictions that experimental physicists can check in their labs right now. It predicts things like exactly how long a quantum collapse should take. It suggests we should be able to find certain harmonic peaks in the signals from the universe. It even predicts that entanglement might behave in subtly different ways than we expect under certain conditions. This is what turns a cool idea into real, verifiable science.
So when you put all of this together, it points to a really profound conclusion about the nature of, well, everything. The implication here is just huge. If a model like this holds up, it means we've been focusing on the shadows on the wall, the matter and the energy, when the true reality is the information that's casting those shadows. It suggests the universe is basically a gigantic informational process playing itself out. And that's the ultimate power of a theory like this. It's not just giving us another interpretation to argue about. It's trying to explain why quantum mechanics works the way it does, starting from a deeper, informational layer of reality. And that leaves us with one last kind of mind-blowing question to think about. If this is right, if the universe isn't made of things, but of bits, and reality is just information flowing along a geometric path, then what is the message that's being written?